For any help regarding mathematical statistics, assignment, help. Visit https://www.statisticshomeworkhelper.com. Email info@statisticshomeworkhelper.com or call us at +1 678 648 4277. Solutions to problem. Problem 1. MIT students sometimes delay laundry for a few days. Assume all random values described below are mutually independent. A. A busy student must complete 3 problem sets before doing laundry. Each problem set requires 1 day with probability 2/3 and 2 days with probability 1/3. Let B be the number of days a busy student delays laundry. What is E, B? Example: if the first problem set requires 1 day and the second and third problem sets each require 2 days, then the student delays for B equals D 5 Is. Solution. The expected time to complete a problem set is. Therefore, the expected time to complete all 3 problem sets is. B. A relaxed student rolls a fair, 6-sided die in the morning. If he rolls a 1, then he does his laundry immediately, with 0 days of delay. Otherwise, he delays for 1 day and repeats the experiment the following morning. Let R be the number of days a relaxed student delays laundry. What is E, R? Example: if the student rolls a 2 the first morning, a 5 the second morning, and a 1 the third morning, then he delays for R equals D 2 Is. Statisticshomeworkhelper.com. C. Before doing laundry, an unlucky student must recover from illness for a number of days equal to the product of the numbers rolled on 2 fair, 6-sided dice. Let U be the expected. Solution. If we regard doing laundry as a failure, then the mean time to failure is 1/1/6 equals 6. However, this counts the day laundry is done, so the number of days delay is 6 minus 1 equals 5. Alternatively, we could derive the answer as follows. Equal to the product of the numbers rolled on 2 fair, 6-sided dice. Let U be the expected number of days an unlucky student delays laundry. What is E, U? Example: if the rolls are 5 and 3, then the student delays for U equals 1 D 5 Is. Solution. Let D1 and D2 be the 2 die rolls. Recall that a die roll has expectation 7/2. Thus, D. A student is busy with probability 1/2, relaxed with probability 1/3, and unlucky with probability 1/6. Let D be the number of days the student delays laundry. What is E, D? Statisticshomeworkhelper.com. Problem 2. There are about 250 million people in the United States who might use a phone. Assume that each person is on the phone during each minute mutually independently with probability P equals 0.01. To keep the problem simple, we are putting aside the fact that people are on the phone more often at certain times of day and on certain days of the year. A. What is the expected number of people on the phone at a given moment? Solution. Let 2 be an indicator for the event that the th person is on the phone. The number of people on the phone is then. Solution. People on the phone is then. The expectation of this sum is 250,000,000,000.01 is equal to 2,500,000 by linearity of expectation. B. Suppose that we construct a phone network whose capacity is a mere 1% above the expectation. Upper bound the probability that the network is overloaded in a given minute. Use the approximation formula given in the notes. You may need to evaluate this expression in a clever way because of the size of numbers involved. For example, you could first evaluate the logarithm of the given expression. Solution. The network is overloaded if the fraction of people calling is greater than 1.010.01 is equal to 0.0101. In complementary terms, The network is overloaded if the fraction of people not calling is less than 1 minus 0.0101 is equal to 0.9899. Define the following variables. StatisticsHomeworkHelper.com. N, equals 250, 000 people in the USP, equals 0.99 prob, not on phone alpha, equals 0.9899 minutes, allowable fraction not on phone. In these terms, the solution to the problem is fn p, alpha n. We can upper bound this approximately using the formula from the notes. By first evaluating the logarithm of this expression, we find that this is about e minus 120. C. What is the expected number of minutes, approximately, until the system is overloaded for the first time? E minus 120 solution. Applying the expected time to failure formula with probability p equals 120 gives 1/p equals e. Problem 3. We are given a set of n distinct positive integers. We then determine the maximum of these numbers by the following procedure. Randomly arrange the numbers in a sequence. Let the current maximum initially be the first number in the sequence and the current element be the second element of the sequence. If the current element is greater than the current maximum, perform an update, that is, change the current maximum to be the current element. Either way, change the current element to be the next element of the sequence. Repeat this process until there is no next element. Prove that the expected number of updates is ln. Hint: let me be the indicator variable for the event that the th element of the sequence is bigger than all the previous elements in the sequence. StatisticsHomeworkHelper.com. Solution. Note that the number of times we update the current maximum is precisely m equals m1 plus mn. Since expectation is a linear operator, we can compute m by finding me for all I and summing them up. Note also that since me is an indicator variable, we only have to find me equals 1. In a random permutation, this happens with probability 1/i. Why? Because all permutations of the first I numbers in the sequence are equally likely, and the largest among them occurs as the last element of the permutation in 1/i of the cases. Thus, where Hn is the nth harmonic number. Problem 4. In a certain card game, each card has a point value. Numbered cards in the range 2 to 9 are worth 5 points each. The card numbered 10 and the face cards, Jack, Queen, King, are worth 10 points each. Aces are worth 15 points each. Suppose that you thoroughly shuffle a 5-2 card deck. What is the expected total point value of the 3 cards on the top of the deck after the shuffle? Solution. Let the random variable x be the total point value of the 3 cards on the top of the deck. Then we can write where the random variables x1, x2, and x3 are the point values of the first, second, and third cards. By the definition of expectation. StatisticsHomeworkHelper.com. Now we can solve the problem by taking the expected value of both sides of our original equation and then using linearity of expectation. B. Suppose that you throw out all the red cards and shuffle the remaining 2-6 card, all black deck. Now what is the expected total point value of the top 3 cards? Note that drawing 3 aces, for example, is now impossible. Solution. The expected point value is the same as before, since expected point value of a single card is unchanged. Nothing in our solution assumed a 52 card deck. Problem 5. A true story from World War II. The army needs to identify soldiers with a disease called CLEP. There is a way to test blood to determine whether it came from someone with CLEP. The straightforward approach is to test each soldier individually. This requires n tests